And then something that's like not as well known, but there's like an important algae that forms under sea ice. So that also depends on sea ice to be there, that then feeds into the entire food chain and kind of supports larger animals like Arctic cod, other fish, ring seals, that then are prey to both humans and polar bears that hunt from the ice platform. So again, this notion that yes, polar bears are this iconic animal, and it's a great way to draw in people, but it highlights how sea ice and this platform is important for the entire ecosystem.
Welcome to Life Saves the Planet, a conversation series presented by Biodiversity for Livable Climate in partnership with the GBH Forum Network, where we bring you authors, scientists, and leaders from around the world to discuss climate change through the lens of biodiversity. We're so happy that you've joined us for this conversation. Thaw and freeze, the ecological, geological, and human stakes of a warming Arctic. We are honored today to be joined by Jon Waterman, the author of the just-released book, Into the Thaw, Witnessing Wonder Amid the Arctic Climate Crisis. He'll be joined by Dr. Flavio Lehner, who is Polar Bears International Chief Climate Scientist. He is also an assistant professor in Earth and Atmospheric Science at Cornell University. I'm Beck Mordini, Executive Director of Biodiversity for a Livable Climate. For over 10 years, Bio for Climate has been sharing the science and the stories of the power of restoring ecosystems to stabilize the climate. Let me start with a little bit more about our speakers today. Jon Waterman found his calling as a writer while shooting photographs on expeditions more than 4 decades ago. He has shot and written television films, including The Logan Challenge and Surviving Denali, and Chasing Water. Jon is known for his northern explorations, detailed in many of his books and countless journals, since 1978. Beginning in 2007, the rivers of the Southwest began to call, with an extended journey and National Geographic Society research projects. His latest book, we're discussing today, Into the Thaw, recounts how his return to one particular place in the Arctic after a more than 30-year absence left him shocked by its change, but also renewed with drive and hope. Dr. Flavio Lehner is Polar Bears International's Chief Climate Scientist. He's also an assistant professor in Earth and Atmospheric Science at Cornell University. He obtained a PhD in climate science from the University of Bern in Switzerland in 2013. After a brief engagement as science officer in the technical support unit for the IPCC Fifth Assessment Report, he joined the Climate and Global Dynamics Lab at the National Center for Atmospheric Research in 2014. After a year as a senior scientist at ETH Zurich in Switzerland, Flavio joined Cornell University as an assistant professor. His research group studies climate variability and change with a focus on physical processes that affect humans and ecosystems, from heat waves and droughts to sea ice trends and precipitation extremes. So we have the experts here, and I'm excited to get started with a presentation that's going to be sure to fill you with wonder, maybe touch on some grief, and we hope leave you empowered to take action. Jon and Flavio, I wonder if you could give us a bit of background on what inspired you about the Arctic and this work. Jon, why don't you get started?
So I have to tell a story, and to do that, I asked you to jump in the time machine with me. In 1983, as a Denali National Park Service ranger, I was sent on an exchange patrol to Gates of the Arctic National Park. And this was the first time I'd been above the Arctic Circle. And you can see that here in our tandem kayak, we were dressed in winter clothing during the last week of August, 37 years ago. Naturally, we never thought about swimming in the river. There were no bugs that time of year, and it was just bloody cold. We saw thousands of migrating caribou, discovered a wolf den with 5 pups, and we watched a grizzly bear consume a caribou. Needless to say that the trip really changed my life, and I quit the Park Service shortly thereafter and began taking many journeys throughout the Arctic. For 2 years, in fact, I worked as a guide here on this Noatak River and gates of the Arctic National Park. And then I began exploring other places in the far north. In 2021, I returned to the Noatak after a long absence, along with my 15-year-old son, Alistair, shown here. And the goal was to share with him, the wonders of this place. But it turned out there was a much bigger lesson to be shared because this place had radically changed since I'd last seen it in the 1980s. For starters, the river was flooded in a way that I'd never seen before. The current was so strong with all this water in the river from the epic 3-day rainstorm that I had to pull the raft hard to avoid crashing into the banks. Potential campsites that I had known about from years, decades past, were flooded over. And in 100 miles of river, instead of the thousands of caribou, we saw only one, nor did we see any wolves. And the place was quite radically grown over. In 2021, Alistair and I went swimming, something we never dreamed of doing back in the 1980s. And it was so hot that we turned the raft up on its side just to get out of the hot sun. I think it reached about 90 degrees Fahrenheit. So Alistair is shown here cooking a grayling that we caught in the river. But by the end of the trip, it was clear that he was quite saddened, as I was too, about the observations of the climate change on the river. I'm going to turn it over to Flavio now.
Yeah, thanks, Jon. Very impressive pictures and real world accounting of this change. Yeah, indeed. I mean, this is probably not news to this audience here. The world has warmed a lot. The Arctic has actually warmed at a higher rate than the planet as a whole. And we actually understand pretty well why. This is like a scientific graph from a recent report that kind of shows global temperature change as we've observed it over the last 170 years in this black line. And this red line is basically our estimate of how much of that has been caused by human emissions of greenhouse gases. So you see that our best understanding is that all of this warming was caused by emissions of greenhouse gases. So it's a very clear influence. And the interesting thing about this particular figure and the report it comes out of, it's from this Intergovernmental Panel on Climate Change and their latest assessment. And the interesting thing is that this is a document that's approved by all the governments around the world. So this conclusion that the climate is changing rapidly, especially in the last couple of decades, and then all of this warming is human caused, is an accepted fact by all governments around the world. And I think that itself is, on the one hand, encouraging, but it also shows that this is really a global problem that people need to sort of work together. And like right now, we just ended like one of these climate negotiations that happen every year, and it's tough going. And we can talk a little bit more about that later on. And yeah, as Beck said in the introduction, I'm a climate scientist. I mostly in my day-to-day life deal with sort of the physics of climate change, but I'm very motivated to bring all of these graphs and things back to human stories and real world accounts like Jon has done. And so my work, especially with Polar Bears International, kind of gets at that. I'll say a little bit more about that later, but the idea is really to bring climate science to conservation issues in this particular case. And I make sure that conservation biologists, people who work in these applied fields, have the latest climate science to rely on. And a lot of communication around this also broadens beyond the Arctic and also beyond polar bears, as we'll see in this presentation, because climate change is really a global issue. And as we'll see also from Jon's accounting, there's no place that's untouched by climate change. So I'll pass it back to Jon, and I'll talk to you a little bit more later.
Thank you, Flavio. So based on those radical changes that I saw in 2021 with my son, I returned the following year to take a 500-mile journey there on the Noatak River to more thoroughly investigate climate change in the Arctic. Video, of course, many still photographs, and meetings with scientists and the Inupiat people. So here we're looking at a feature in the landscape that is called a thermokarst. And these thermokarsts are areas that are occurring across the circumpolar Arctic, where the frozen soil underneath the ground is thick as a half-mile down, are beginning to thaw and the ground collapses. Mostly these appear as on flat ground as sinkholes, and you'll see in a moment what they look like on mountainsides and hillsides. And so that's the reason for the title of my book, Into the Thaw, which refers both specifically to this massive permafrost thaw going on throughout the Arctic, as well as the warming in general. I learned after that 2022 investigation that the Arctic is now known to be warming nearly 4 times faster. That's nearly 4 times faster than the rest of the Earth. So this image is inside that last thermokarst, that last 200-yard football field, double a football field size piece of melting earth. And this is what we refer to as maybe you can see, Flavio, can you see my mouse pointer here?
I do, yeah.
This sluice canal here is freighting tons of silt and muddy, thawing permafrost water down into the river. You can just make out a canoe passing by on the Noatak River. And downstream of these thermokarsts, the river would typically turn black for a mile or two, wreaking all kinds of havoc upon the aquatic life in the river. So one of the many things that makes the Arctic unique and very different from where we live in the lower 48 or the southern biosphere is that the ground is underlain by permafrost, which is collectively mostly frozen soil, but also like what you see here, chunks of frozen ice. They've measured permafrost as old as 660,000 years old. And again, as I said before, almost a half-mile deep in many places. And it stretches down into the subarctic and even down as far south as southern Alaska. As early as the 1980s, I saw many of these areas of permafrost banks along the Beaufort Sea, which is part of the Arctic Ocean, begin to collapse because of the lack of ice. And this shoreline, in fact, the Beaufort Sea shoreline, is the fastest eroding coastline of the world because of the lack of protective sea ice. So across the north, permafrost thaw is dropping houses and roads all cattywampus, like this Inupiat man's house here in Noatak village, as well as damaging pipelines. And in this particular case, at this man's house, he's lost both his sewer and his water line because of the permafrost thaw. So I wanted to impress upon folks that the Arctic is well inhabited. There are 4 million people that live above the Arctic Circle. That's that somewhat arbitrary line you see here at 66 degrees, 33 minutes north. 4 million people, most of them are in Russia, but here in Arctic North America, there are 260,000 people living above the Arctic Circle. That includes about 60,000 in Alaska. These people are mostly in North America referred to as Inuit, or in Alaska, Inupiat, formerly called Eskimo. So here, amid the wildfire haze, in one of many unprecedented wildfires, you can just make out left of center on the edge of the image that the Noatak River is flooding, and it's already taken out a road here in Noatak Village, it took us several weeks to get here during our 2022 journey. And it now imperils the landing strip, that is a crucial supply line for the Inupiat village of Noatak. So you can also see that is wildfire haze here on the horizon. That summer of 2022, 3 million acres burned throughout Alaska, and most of that smoke clung to the Arctic. Wilderness is a very different thing in the Arctic. It has a very different meaning than it does here in the lower 48, because there are people like the Inupiat of Noatak Village that depend upon the resources in the Arctic. And they have lived here for several millennia. And because of this, what I refer to as a climate crisis, they have to adapt in startling ways. Here is another village you can see just above the center of the image, the island village of Kivalina. This is along the Chukchi Sea, where we finished our 500-mile journey in 2022. The Army Corps of Engineers has predicted that this village will be inundated by the end of next year. So you can see that they have recently built a road which will allow the people to evacuate to higher ground. But these are coastal people. So this, as you can imagine, would be a great hardship. And this is only one of dozens of villages across the north that in North America, or in Alaska alone, dozens of villages that are imperiled by the climate crisis. We began our journey 2 years ago in Kalulutuk Creek, myself and one other photographer. This creek would have been called a river anywhere else in the world. But I draw your attention to this image. In the distance, you can make out what you might perceive as landslides. Well, these are more thermokarsts, where the permafrost thaw has collapsed and the water has begun to melt out of the frozen soil and ice and flow down the mountainside like a river. These thermokarsts are appearing throughout the circumpolar Arctic, on hillsides, mountainsides, even on flat grounds, often in streams. It is not a benign phenomenon. But also in this image, you can see that it's very brushy, and we had anticipated being able to follow caribou trails, but because of another phenomenon known as the greening of the Arctic, we were forced to line our pack rafts up the river rather than try and even attempt this epic bushwhack here. So this is a photograph of my friend, the great wildlife biologist, Dr. George Schaller, in the Arctic in 2006 during a National Geographic investigation of climate change in northern Alaska. And here we're in the Arctic, just north of the Arctic Circle, passing through an area that has burned down in 2004. And fires had burned from horizon to horizon here, right on into the fall. If this, size of fire had happened anywhere in the lower 48, it would have been a major disaster. But because most of this area was uninhabited, it went unremarked. And then again in 2005, the following year, fires caused the greatest smoke event in the history of Alaska. So the most amazing thing about these fires is that for tens of thousands of years, there have been no fires in the Arctic. Incidentally, Dr. Schaller is examining the species fireweed, which is the first species to recolonize after a forest fire. And I hasten to add that there are countless moments of wonder and beauty that I found throughout the Arctic, whether these transformations are going on or not. It is still an amazingly beautiful place. That year, 2006, we continued north along the Dalton Highway and on the northern slope of Alaska, along with several graduate students. We stopped at a place called the Toolik Lake Research Station, and a plant ecologist there showed us a small greenhouse which had been set up more than a dozen years previously. And you can see the outside of this greenhouse. There's a dwarf birch species, which is ankle and knee high. But inside of the greenhouse, it's a completely different matter because the warming several degrees over a dozen years has allowed that dwarf birch to grow chest and head high. And this very neatly illustrates the greening of the Arctic, that phenomenon that is occurring across the north, part of what's known as the Arctic feedback loop, caused by such things as the diminishment of the sea ice and the lack of reflectivity across the land. So here is a picture from the top image was taken on the Noatak River more than a century ago. And I recolored the photograph to show those areas where there was no greenery. And the greenery that does exist on the tundra is basic tundra species, which we mostly had come to expect in the Arctic, sort of ankle-high Lilliputian plants, this small world of wonder. But a century later, when I rephotographed it, more than a century later, when I rephotographed it, these plants here, the dwarf birch and the willows, are head high. And here you can make, in the center of the image that I took, you can make out a stand of poplar trees 20 feet high. So you're probably asking yourselves, well, isn't this a good thing? Because we know of forests as climate sinks elsewhere in the world, and that is true. They absorb carbon dioxide. But here in the Arctic, there's more than a net loss, because this plant growth actually absorbs heat from the sun, or the trees, new tree growth and plant growth pokes through the snow, and reflectivity is lost. And also the greenery, the greening of the Arctic phenomenon, is drawing animals north that in turn alter the ecosystem in other ways. Down in the first of the boreal forests, still in the Arctic Circle, north of the Arctic Circle, making our way toward the Chukchi Sea, we saw a lot of this quote unquote drunken forest. And this is occurring throughout the circumpolar Arctic, around the world, and as far south in Alaska as Anchorage in Denali National Park. When the permafrost thaws, those tree roots lose their foundation and the trees begin to fall over drunkenly. So again, another example of why the greening of the Arctic is a net loss in terms of offsetting greenhouse gases. This is landfast ice. On one of my many trips across the Arctic, and this shoreline ice, which began to disappear, beginning several decades ago, allows this shoreline to be battered by storms. And this is why the Beaufort Sea is one of the fastest eroding shorelines in the world, the fastest eroding shoreline in the world, and in turn, endangering villages like that previous image I shared that we shot with a drone of Kivalina village in the Chukchi Sea. Without that sea ice, villages are imperiled. So whether the Inuit of Canada or the Inupiat of Alaska, as I mentioned, they depend upon the animals for food security. This woman, an Inuit woman from Cambridge Bay, Nunavut, is catching Arctic char and Dollyvarden out on the sea ice in April. And her people, her ancestors, have depended upon the sea ice for thousands of years. It happened that the sea ice was thick that winter, fall and winter of 1998 and 1999 when I took this photograph. And here you can see the reflective quality, of course, of the ice, and you can see how deep it is here near the shore. And this reflective quality is what's known as albedo, reflecting the heat of the sun back into the atmosphere and keeping the Arctic cold. But of course, with the loss of albedo, as you can see here in this image that I shot several months later, I was traveling alone. I traveled 2,200 miles across the Arctic, mostly alone. I shot this photograph holding a remote in my hand with a camera mounted on top of my mast. But you can see how dark that ocean is. It's part of the Arctic Ocean or the Beaufort Sea. And that ocean, without the sea ice, is absorbing lots of heat. And that lack of albedo is one of the crucial dominoes in the Arctic feedback loop. And these dominoes are knocking one another over, and everything becomes warmer. Here in this map from the end pages of my book, Into the Thaw, created with data from the Permafrost Atlas and a sea ice map from the Oceanic Atmospheric Administration, the National Oceanic Atmospheric Administration, you can see the areas here in dark orange in the top of North America. And of course, this is happening around the world, but we're just showing North America. These are areas of abrupt permafrost thaw. And you've seen now the effects, the thermokarst that are caused by this abrupt thaw. And in turn, what's happening is that as the permafrost thaws, there's ancient plant matter and even animals, dead animals, of course, inside of the permafrost. Microbes begin to consume this plant matter, and carbon dioxide is released, as well as the more potent greenhouse gas methane, increasing, of course, greenhouse gases and accelerating climate change. And this is one of the great wild cards of Arctic warming. This permafrost thaws is equally as potentially catastrophic as the loss of sea ice. Now, I want to call your attention also to the loss of sea ice, which you can see here. The blue line represents the average extent, summer extent of the sea ice from the years from the 1980s until more recently. And we are losing approximately 28,000 square miles of sea ice a year in that time. Well, last year, this dark blue area shows where the sea ice, the summer sea ice, has melted back to. And now, of course, as that sea ice melts, the ocean warms, and in turn warms the adjoining land masses. Scientists have predicted that as soon as mid-century or as late as the end of the century, that the summer sea ice will be completely gone. I'm going to turn it back over to Flavio here.
Yeah, thanks, Jon. That's really impressive to see these pictures, and you've traveled more than probably most in the Arctic and beyond, so it's fascinating to see. My first encounter with the Arctic and then sea ice specifically was back in 2009, so not quite that long ago, but still starting to be long enough to go back and see how it has changed. I was still a student studying climate science in Switzerland, but I had the chance to go on the German research icebreaker called Polarstern into Fram Strait, which is kind of between Greenland and Svalbard, sort of in the far north of the Atlantic Ocean. And this is a picture I've taken sort of looking backwards from this icebreaker as it was cruising through actually pretty thin ice off the coast of Greenland. So this was not very hard work for the icebreaker, but it was just a fascinating picture to take. And I could look at sea ice all day. To me, it's like endlessly fascinating how, just like you described, Jon, how just with a few feet of ice, you can completely transform an entire landscape, right? This is like going from dark, deep ocean to a surface that is white and reflects a lot of sunlight and is an important component of sort of the air conditioning of the Arctic and our planet to reflect back solar radiation. This transformation requires nothing but this little layer of ice. So it's incredibly fascinating to just think about that when you see it in person. But then beyond that, actually, sea ice is also, and the formation of sea ice creates almost a new habitat, which is like this platform that animals both on top and below can interact with, and like makes it an incredibly interesting and important sort of ecosystem. So I think if you go to the next slide, Jon, we can see. So at one point we were kind of sitting there on our icebreaker just between Greenland and Svalbard, and we were servicing some moorings. So like there's some measurement stations that measure ocean currents and salinity year round, and they have to be serviced every other year. And so we were doing that, and at that moment, like a polar bear using this platform and his habitat was coming over to kind of check us out. It could be that he was still smelling the German sausage that we had for breakfast. This being a German icebreaker, there was a lot of sausage, I have to admit. And so, yeah, the polar bear is a kind of a prime example, but as we'll see, by far not the only one that really relies on sea ice as a habitat to move around. And since this is like kind of drift ice, it's like actually Fram Strait is like a region between Greenland and Svalbard where a lot of ice is actually being exported by ocean currents from the Arctic Ocean into the North Atlantic. So a lot of this ice, you can't see it in this picture, but a lot of this ice is actually moving sometimes at a good clip. And it was also just fun to watch the polar bear navigate this and jump from one ice piece to the other. So yeah, very fascinating experience. And so yeah, this schematic here is really the opportunity to kind of show how sea ice, besides permafrost, is really this important component in the Arctic system. And it doesn't just affect polar bears, it affects people. And Jon gave some excellent examples, both for like acquiring food, but also transportation for people. And then something that's like not as well known, but there's like an important algae that forms under sea ice, so that also depends on sea ice to be there, that then feeds into the entire food chain and kind of supports larger animals like Arctic cod, other fish, ring seals that then are prey to both humans and polar bears that hunt from the ice platform. So again, this notion that yes, polar bears are this iconic animal, and it's a great way to draw in people, but it highlights how sea ice and this platform is important for the entire ecosystem. Yeah, Jon has already touched upon this, but if we kind of just look at the latest science when it comes to what's going to happen to Arctic sea ice, it's relatively straightforward. Unfortunately, on a warming planet, sea ice will disappear. We're seeing here a time series again from this latest climate change assessment report that shows this the extent of the Arctic sea ice area going from the 1950s and then projected forward into the future until the end of this century. And in all of these different scenarios, we see that sea ice is declining. The different scenarios have actually very different assumptions about how much greenhouse gases we emit in the future. But as you can see, in all of these scenarios, sea ice is declining. There's still a lot of variability in there and like things to figure out for scientists. Right now, we are roughly on the trajectory of this orange line that you can see in the middle there. So we're like not on the worst case trajectory, but definitely also not on the best case trajectory. That's probably something you can glean from some of the news about these climate negotiations that are happening right now. And the important component, maybe if you just go back one brief second, is this line where the Arctic is ice-free. Right now, we are really on track to have an ice-free Arctic in summer by the end of this century. But if we do reduce emissions, we could end up on any of those two blue trajectories, which still has a large reduction in sea ice, but it maintains some of this critical habitat by the end of the century. And I think this is the last scientific graph that I'm going to throw at you, but as a scientist, I do have to kind of like bring up some of these things and try to convey them. But this is a really a cool and valuable study that's been conducted recently by people from the organization I partner with, Polar Bears International, and a couple of universities. And what they've been able to do is to directly link the extent of sea ice in a given year to the number of days that bears are forced on land and then have to fast. So bears can only hunt from sea ice. And so if they're forced on land because there's less sea ice, they have to fast. And normally that's not a problem. In fact, polar bears are the mammals that can fast, or with the longest fast duration. A female polar bear in a den can go without food for 8 months. But ultimately, this extended fast duration has been shown to start to affect what's called cub recruitment, or like how many cubs a female polar bear can have, and then also how many of those survive. And this direct link between how long they fast and how they struggle with recruitment basically then leads to this projection that with sea ice declining, polar bear populations will start to decline. And some of these results are from some of the best studied polar bear populations. They, not surprisingly, are the ones that are sort of more subtly, so they're more directly or more sooner affected by climate change. The important component of this study, though, that has broader relevance beyond polar bears is that the link to greenhouse gas emissions has been proven for the first time in these studies. So you can see this by these regression lines that are all sort of very clearly pointing in one particular direction. And the value in that is that now this can be used directly in making policy about future projects that would explore more fossil fuels. Because as such a project, it would have to prove that it is not damaging to endangered species like polar bears. But because the science shows this clear link, this is now much more difficult to do, and fossil fuel projects will have to overcome the burden of evidence that this is not damaging, in this case, to polar bears. But the important thing about this study is it's a blueprint, a template for other studies and other animals and ecosystems more generally that can be used to inform policy, right? If we can prove this link, and Jon has all these examples of other parts of the Arctic ecosystem and animals that are affected by climate change, if we can prove that some of the greenhouse gas emissions that are going on and are planned are damaging to them, this can be used to produce policy that better protects the environment going forward.
Thank you, Flavio. So, of course, there are many animals that are affected by this warming. I talked about the caribou. The caribou that I encountered most recently are from the Western Arctic caribou herd in northwestern Alaska, the biggest herd in the Alaskan Arctic. This is a photograph from my book by Seth Kantner, who has lived in the Arctic for 50 years. But this herd had reached its apex a couple of decades ago, 500,000 animals, but the latest census puts their numbers at 152,000. So it's an enormous shrinkage. And this is happening to almost all of the herds across the circumpolar Arctic because of habitat loss and climate change. I photographed these musk oxen here on an island in the Beaufort Sea in 1997. It's truly an extraordinary species, a remnant of the last ice age, but one of the many animals imperiled. For instance, in October 2003, a rain on snow event, in other words, one of these anomalic warm winter rains came and iced over the snow, and that killed approximately 20,000 muskoxen on Banks Island in the Canadian Arctic archipelago, reducing the herd on that island by about 25%. And it shows how the warming Arctic endangers the other grazing animals, including the caribou and the Dall sheep, because the animals can't kick down to their graves through the iced over snow. This is another invasive animal, the beaver, which we all recognize, has now made its entree into the Arctic. And they're drawn into the Arctic, of course, because there are now willows there that didn't used to be there, and they eat the willows and then use the stouter branches to make dams. This shows in a small tributary near the Noatak River in northwestern Alaska in 2003, the river, pristine river here, and fast forward the time a little more than a dozen years later to 2016, they're the same tributary, nearly unrecognizable because the beavers have come. The researchers that have done this study used these satellite photographs and actually counted over 11,000 new beaver dams just in this little section of Northwest Alaska. As for what this ultimately means to the Arctic ecosystems, only time will tell. Here on the Noatak River, just 2 years ago, I saw more than a few red foxes, which used to range only as far as tree line, but now they're making their way north of the tree line and all the way up into the high Arctic. And as the temperatures continue to warm. So that red fox has now begun to dominate over the meeker Arctic fox, which you see here. I photographed this Arctic fox in outside of Churchill, Manitoba, more than 20 years ago. And Flavio, who has actually been to Churchill, Manitoba quite recently, has told me that now you see mostly red foxes there. So yet another strange change, and just a few examples of the way the wildlife are affected. So again and again in the Arctic, I have encountered a myriad of beauties and wonder. And it's starting with its vastness, like here in the Noatak River. And then there's, of course, the amazing wildlife and this phenomenal, noble Inuit and Inupiat culture. So I want to leave you with the first 2 pages of my book for wherever you might go, to a local park or the Arctic, with this image of vast landscapes and the words from the esteemed author E.B. White. Always be on the lookout for the presence of wonder. Thank you.
Thank you, Jon and Flavio. Flavio, any other last words on that?
It's hard to top that, yeah, but as I said, the Arctic and vast landscapes in general are equally fascinating to me. I think it just provides this opportunity to gain perspective of the beauty of nature, but also like how large it is. But then like, yeah, these accounts of like going back to a place and seeing how much it can change, it just shows you how rapid and profound these things are, that they can change entire landscapes over the course of decades. So it's both fascinating, but also frankly a little scary at times.
Well, you have seen some of the highlights from Jon's book. I'll have to say, as I've been reading this book, the stories behind those pictures are amazing and somewhat life-changing. The first section is about the earlier travels, and like Jon said, some of that was thousands of miles of that was a solitary journey, and sharing the way he shares that journey with you changes you with him. I mean, I've really found it quite impactful, and it's reminded me that the value of wilderness, we're focused on climate and we need these ecosystems to be functioning, but there is a value for humanity to have wild places as well, and how they affect your soul and who you are. And that really comes through in the stories of the early explorations and the later ones. I feel blessed to have gotten to share that journey with you, Jon. Thank you. We are going to now take a look at some of the questions that people sent in ahead of time, and this is a good time to put questions that you might have in the Q&A section. I see some people have quite a few resources that they'd like to share. Hopefully those can be shared in chat, that Frederic may be able to pick those up. But I think we'll stick to questions that, as opposed to resources for this section. As I looked over the questions, there's kind of 2 types of questions about the science of what's going on, and then a lot of people had questions about the solutions. I think we'll wrap up with solutions to leave us all with a little bit of agency and hope, and try to group some of these science questions together. I think there's a really nice question to start this off with that may seem counterintuitive, but someone from Taiwan is asked, when and how does this affect different regions of the world? So if you don't live in the Arctic, how is this affecting you? And either one of you could take a chance.
I'm happy to take a stab at that. It's a great question. And climate change, I think, beyond the Arctic, it's affecting humans and ecosystems globally. We can talk a little bit about this idea that changes in the Arctic themselves affect weather patterns around the world, but I would keep it much more broadly that climate change is a global problem. I mean, specifically in Taiwan, you're not worried about disappearing sea ice, of course, but I think that island historically has been pretty vulnerable to hurricanes. So that's a topic that researchers are paying close attention to. Like the latest science there would, for example, suggest that hurricanes will become stronger and will tend to dump more precipitation on you if they do occur. We're not quite sure about whether they will become more frequent, but the mere fact that if you do have hurricanes, and they will become stronger in a warmer climate. That's probably a main concern for this region of the world. And generally in the tropics, heat stress is a big issue. There's regions where we're not quite sure if humans can always survive outdoors by the end of the century, depending on how much we warm, just because it's going to be too warm and humid to live. Taiwan obviously has a lot of infrastructure to adapt, but other tropical regions do not. And so it always depends a little bit on where you live, but it's a great question.
Jon, did you want to add anything else to that?
No, I think that was the perfect answer. Thank you.
Okay, great. For Flavio, so some people are familiar with the AMOC currents, and maybe that also goes to a little bit to the first question too, how the melting ice affects world. If you want to explain to our audience what the AMOC is and how it's affected by this melting ice, that's one of our questions.
Sure. Yeah, I'll try to keep it brief. AMOC stands for the Atlantic Meridional Overturning Circulation, and it's an important ocean current in the Atlantic that kind of brings warm waters to higher latitudes like Europe, and generally contributes actually to Europe being warmer than at the same latitude in North America. There's this famous comparison that New York, I think, is at the same latitude as Rome, but obviously they don't have the same climate. Rome tends to be much warmer, and that's partly because this ocean current brings a lot of warmth to that region. It turns out that this ocean current is driven by density differences in the ocean. And so those can be affected by both warming temperatures. Warming waters have a different density, as well as if there's meltwater coming into that region from sea ice, from melting ice sheets, that also tends to freshen the water and change its density. And what studies show is that the combination of these things tends to slow down this current, eventually, potentially, to the point of collapse. And that would be a pretty dramatic change where this warmth that normally feeds into the North Atlantic through this current would suddenly stop. And so some regions would see pretty dramatic, actually cooling. Parts like Western Europe, Scandinavia would see a dramatic cooling even in a warming climate. It's fair to say that it's not quite clear whether this will actually happen and when, but there's a tendency and the understanding that this ocean current is slowing that's there, and that's very concerning.
Jon, we had some questions about the people who live in the Arctic. And the two types of questions are, what are the effects on the people who live there? And I think you did touch on some of those effects. Maybe you want to tell us a little bit about who you visited. And were the elders expressing concerns during your first visit so many decades ago? Or is this fairly new?
I think that it's a great question. And I think that an important question, because we always have to look at the cultural ramifications of the warming Arctic and not just think of it as a remote, uninhabited landscape. And it was first brought to my attention in 1997 during a long solo journey where I met with an elder who lived on Banks Island, the same place where there's a radical muskoxen die-off in the Canadian Arctic. And he said that prior to the 1990s, he'd never seen robins and bluebirds, and that beginning in the 1990s, robins and bluebirds had come to his village, or that they used to hold sled dog races every 4th of July, but beginning also in the 1990s, there was never snow left past the end of June. And I would hear comments like this repeatedly. It's one of the things that drew me to write this book as early as 1997. Another elder that I met outside the village of Paulatuk in the Canadian Arctic that had recently shot and killed a moose, and he'd never seen a moose so far north before. And that even though the people there in that hunting camp hadn't had anything to eat for a long time, they were kind of reluctant to eat this moose because it was strange to them. So they are an incredibly tough people collectively, the Inuits and the Inupiat and the Yupik people, arguably the toughest people on the earth, who have adapted to change again and again over the millennia, arguably all the way back to the last ice age, in times of when the caribou herds had faltered and the numbers had plummeted. and food security dropped. But now, as I've shown you with many of these images and stories, their future is really quite uncertain. But again, they have a resilience that is uncanny to observe. They have a sense of humor, and they are still, however, trying to find ways to cope with these radical changes.
So there were a couple of questions about other effects of the warming and the melting ice. Things such as, I think you touched on species loss, but maybe disease or methane, more carbon dioxide. Are there any of those things that you'd like to add on to or elaborate on a little bit?
John already nicely described how a big concern, like a wild card in Arctic climate change, is the melting permafrost and how much additional greenhouse gases will come out of that. It's unfortunately, we don't know very well. It's very difficult to both observe and also like put into computer models to predict forward how permafrost is changing and how much carbon might be and methane might be released. It's true that right now, a lot of climate change projections are a little conservative about that. So if this would unfold to be sort of worse than we think, then this would lead to additional climate change and warming. And so it's something that the scientists are working on pretty frantically, both like go into the Arctic and observe it, but also put the knowledge gained into computer models to refine those projections. So we're not getting unpleasantly surprised. But it's again one of these things that we know the risk is there, and as a consequence, the logical thing would be to try to avoid that risk and not try to find out.
Well, exactly. So all these individual consequences that we've talked about add up to an ecosystem that's not functioning the way that it was designed to function, right? And that is part of the stress on our climate system, as you put them all together, that affects not only the lifestyles of the people in living in those areas, but all of us, right? It's accelerating the consequences around the globe. So I think that's kind of pulling those pieces together. Well, we have a few more minutes for the happy, hopeful part of this talk. We talked a little bit as we were all talking together about wanting to leave people with agency without downplaying the risk and the position we're in. And so if you could each talk a little bit about what we can do, what are the solutions that you think are most useful. I think before we get to that, though, there is one specific question. Some people propose geoengineering as a way to quickly cool the planet. Maybe sometimes that's increasing albedo. Have either of you looked into those, and do you have information or views on whether they're a good idea or not?
I have examined it and would like to learn more. And these geoengineering things involve, pumping carbon back into the ground, for instance, alongside oil wells, or emitting particles into the air, sulfur dioxide potentially, that would block the rays of the sun and simulate a volcano, or even more cleverly, using particles that would increase the albedo and reflectivity of sea ice and glaciers. And there are probably dozens more examples of geoengineering. And I think that, well, on the one hand, they could open a Pandora's box and cause something catastrophic, for instance, mimicking a volcano. We do have to do something, and I think that all of these geoengineering things with caution could be tried out.
Yeah, it's interesting. Oh, sorry.
Go ahead.
There's actually just a paper, at least a preprint, published this week by sort of a who's who of polar research and climate research, that at this point strongly cautions against any of these methods because they're not tried and tested and are not feasible. But as you point out, John, when there's a problem, humans look for solutions, be it to actually fix the root cause problem or the symptoms, right? We all know, like we have a headache, we first take a Tylenol and don't go to the doctor in the hope that's going to, be enough. But I think that's the key thing to understand with at least some of these geoengineering solutions, for example, reflecting solar radiation back, which has a good analog in volcanic eruptions. It doesn't fix the root cause of the problem. For example, you'd still have ocean acidification because we would commit to emitting more greenhouse gases, carbon that then goes into the ocean and so forth. But it's also true that sort of the train has left the station or the cat's out of the bag. Like this is being looked at. And so it's important that if it's being researched, it's done like in the public, at public universities and in a transparent way. Because at the end of the day, something like controlling the weather and the climate has huge policy implications. And so the more this research can happen in a transparent way, the more likely we are to make the right decision whether or not to deploy it.
Yeah, it's something we're investigating at Bio for Climate as well, just trying to learn more about it, really. There's two great questions left. I don't know if we'll have time for both of them. We only have a minute left. One of them is about how you talk to young people. And someone asked specifically, John, how you and your sons talk about this. And someone else asked, and maybe Flavio, about how you teach children. And they asked particularly about middle school, but I know Flavio has done some curriculum for school children. So that's one of the issues. And the other one was about how Indigenous people are preparing and if there's ways that they're being programs to help them. And so whichever one of those you'd like to talk about, we will only have time to answer one question.
Well, I'll jump in quickly and say that for instance, in Noatak Village, they're installing solar panels. And I asked an Inupiat man there what could be done about climate change. And he very gently sort of said, well, as one of the people that has done the least, one of the populations that have done the least to cause climate warming, he said, well, maybe the people down south could reduce their emissions. And he said it in a very polite, gentle way. And to my son, whom I traveled with in the Arctic several years ago, and dealing with this, being sad about this state of affairs or suffering from what we might call climate anxiety, my reaction to him and to other young people, what can we do? Well, take action. There are many ways we can take action. I'd like to refer people to the United Nations website. It can easily be Googled, take action for a healthy planet. And there are a list of things that include such things as change your home's source of energy, save energy at home, walk, bike, or use local transport, switch to an electric vehicle. Consider your travel. Airline travel is an incredible greenhouse gas emitter. Reduce, reuse, recycle, and repair. Eat more vegetables. Throw away less food. Plant native species. Clean up your environment. Make your money count and speak up. Vote. And if you can't vote nationally, try to influence things locally. But I'll let Flavio continue from there.
Yeah, no, those are excellent points. I mean, I will just add the voting one is critical. That's really the strongest thing you can do. Vote for people that really put in place policy that put the environment first. I will also say that, like talking to younger people, for example, who might not yet be able to vote, we found through our work with Polar Bears International that is one of our key goals. We do a lot of, as you said, curriculum development and webinars with middle school classes. And that's why the polar bear, in this case, is an excellent hook. Kids care about animals, but they also care about things they've actually already observed. It can also be less exotic animals and environmental situations around them. So that's a good starting point, like something they really care about. But animals tend to kind of like hit that spot. And then ultimately for young people, if you cannot vote yet, talk to your parents. Like, and the same goes actually for adults. Like conversation makes more people aware of this. It brings it up in a broad societal discussion. And so just talking about climate change and your concerns will like keep this topic, this important topic, on the top of the agenda. And then, I mean, I have the privilege of teaching at Cornell University. The students here tend to be excellent, but even they sometimes have what Jon described as climate anxiety. And it's a big challenge because these are some of the best educated people that will lead society in the future. And so we really need them to be optimistic. And I think there is reason to be. I was a student myself and was dealing with something like climate anxiety, but I've also seen the progress we've made since then. So there is a track record of us doing some things right if we invest in the right way.
Well, thank you. And I hope you don't mind if I add just a few words about how we address that at Bio for Climate as well. And we're looking at how to draw, not only to prevent emissions, but how you draw carbon dioxide out of the atmosphere and the air. And we know that nature and photosynthesis is one of our most powerful tools that is already present for us, doesn't require new technology. So we're looking at conserving existing ecosystems, particularly forest ecosystems, but also eco-restoration of forest ecosystems and grassland ecosystems, starting from the soil and the microbes up, right? And people can find a lot of information about that at our website. But what we have found is being in action is your best cure, right, for eco-anxiety. And people who join us to plant a mini urban forest or participate in other ways know they're doing something, right? And that is the best thing, like you said, to be in action. And so couldn't agree more. And we don't know how far that'll get us, but that's all we can do, right? Sometimes people will come to me and say, we're not going to make it. And I say, we just have to keep moving forward. And so, and these beautiful places really inspire us to do that. Thank you all for joining us this evening. Let's carry on in partnership with nature. Thank you.